Hey there, and welcome back. Whilst watching the latest Marvel movie, and by the way, I love them, I asked myself, how does a 3D glass works? And that's why I took one with me, and I want to look inside and then explain how it works. But first of all, let's open the plastic thingy. And then we see roughly there's some little notch where we can put our knife in, so I hope I can crank this thing open. So it's basically just these plastic thingies. So basically what it comes down to is polarization. But before we talk about that, we want to show you two experiments which are, I think, hilarious. So the first one is we have a light source and we take the two plastic pieces from our glass, and now you see that the light changes the color. And now when we turn one around, it blends the light, so it reduces the intensity. The second experiment involves a mirror. And if you now take your two glasses, you see that the one which you're looking through, this one, is turning black and the other one is transparent. And now when we move them, you see that it changes. This one is now black and this one is transparent. So why is all of this happening? So let's get into polarization shortly, and I think it's understandable even if you don't have any physical background. The first question is, why do we need polarization for 3D? So you know that you can see an object in 3D because you have two eyes and your brain calculates the image for the object. But now we need to get two different images on the same screen, and it should only be dedicated for one eye. So that's the issue. And of course, the cinema doesn't want to waste a lot of money in those electrical shutter glasses that sync with the projector. So you need some kind of fancy way to solve this. So, first of all, we need to talk about linear polarization. And basically, a light is a wave. So we have a wave like so. This is our light. And now we can filter these lights, because light can alternate in this direction or in that direction. Then it would be like this, or like with a 45-degree radius. And you can block this light when you make a mesh that has long lines, and now when the mesh is like this and our light source, which is our light is traversing like this, now it can't get through. But if we do it like this, it can get through. So what you might think now is, well, we have one lens that has these meshes and one lens that has one like this. And yes, it would be possible that now the projector is projecting the image for the left eye with a light source that is alternating in this direction, and for the right eye, like so. But we have one main problem with this design. Your face or your head would need to be perfectly aligned with 90 degrees. But when you move like this, then, or let's rather say like this, but your light still comes in the same angle, you see now that it doesn't fit quite through. So we need another solution. And this solution is really, really clever. So what we can do is, adding to that one light, we can add another light ray, and this would, let's say, alternate on this axis. We have here our axis, like so, and it would alternate up, down, like so. So I'm really bad at drawing, but I hope I can get this. Like so. So. And now, as we learn in school, we have two vectors which add up. So one is going that direction, one is going that direction, and the vector which exists in reality is then this one. So basically what we create with two light waves being on a cross, you could say, and having the same 0 points on the same touching points with the axis, is a light beam that is with 45 degrees. Yeah, so because you would have one here, and then we would do the same thing here, and we would get one like this, and then you see it's like 45 degrees in. So now we can do something, and that is to have our first light, like so. That's our first light wave. And we are in this axis. And now we add the second one, which is on this plane, but we have the touching points when the first light has a maximum. Like so, we have here our axis again. And now this is like this, like so. So now when we add the vectors, we get a circle. And now depending on how the second light is moved towards the first, we can get a rotation into our light. And this rotation is depending on how it is and how it is, and how the relations right or left. And this is what we call circular, or what the internet says calls circular polarization, or circular polarized light. And now what we can do to, and what actually the two pairs consist of, is a wave plate and a linear polarizer. A wave plate is effectively this. What it does is to depending on the thickness and the material you use, to move one of these lights depending on how they want to pass the crystal. And this is done that the crystal has different light speeds, how it lets through the light. So this turns the circular polarized light to linear polarized light, and this linear polarized light can then be let through a polarized filter or blocked by a polarized filter, so that each eye gets the dedicated image. And now that we have the theory out of the way, we can now rip these small things apart and see if we have two layers. So the transparent part is the wave plate, which is actually just some plastic. And this one is the linear filter. So let's get all of it off. So now that we've covered everything, I want to put everything we learned together. And so we have our two lights, and they are both separated by a quarter of the wavelength. And then the first plane should represent the wave plate, and this what this does is that the light that lays on the plane of the red and green axis is delayed by a quarter of the wavelength, so that when we look at both of the lights, they are now synced, and like the 0 points are matching. And then we have here a linear polarizer, which just lets light through, that is in the 45 degrees axis on the yellow one. So now that we cover that, we can switch on the resulting light, and I just put away the other light so that it gets clearer. So now we have our circular polarized light that is turned from the quarter wave plate to a linear polarized light, and now from our linear polarizer, in this case, not let through. We see that everything starts spinning. I can even increase the speed, maybe, like so. And you see that it is not going to pass through this linear polarizer, and that it is always going to stay in this 45-degree linear light, but not able to pass the filter. So now, when we change the rotation of our light, and when we now start our simulation, or yeah, it's already starting. When we now start our simulation, you see that our linear polarized light is again in 45 degrees, but a little bit changed. And it is changed so that it now is able to pass our linear polarized filter, as you can see right here. And that's basically one polarization is for the right eye, and we have this linear polarizer, and on the other eye we have a polarizer which is like exactly the opposite. So that is how 3D glasses work. I hope you've liked it and understood everything. If you did, then please leave a like, and if you really enjoyed it, then please subscribe. Stay curious, and bye.